So remember, if you get your notes turned in by the end of today, 11:59 today, I know it said like they were due originally on Friday, but when I sent out the email, it says as long as everything's completed by today. So even if you turn them and it shows late today, they're not really late. That was just the original due date. I will still give you the extra credit as long as you complete this test by the end of today. Then you'll get 5 points extra credit on today's test as well as your cumulative exam. Same thing as final review. They word as a cumulative exam. Sometimes our references final review. Those are the same tests. So I'll add 5 points to that as well. So let's go ahead. Let's get started with the review. If you guys have anything that you guys need between now and taking your exam, whenever it is, you can join Zooms. This is our last live lesson. There are no more live lessons. I'm just here for anything that you guys need. Tomorrow, so Tuesday and Wednesday is going to be testing. So I won't have normal Zooms then for you guys really. I mean, you could sign if you needed something in the middle of testing, and you could do it through chat, but if you're testing, then it's not going to make a difference. So tomorrow and on Wednesday is testing. So then Friday we'll be back to our 10:30 Zooms if you want to check in for anything. Or did I say Friday? Thursday, and then till the end of the semester. So, all right. Let's go ahead. Let's look at our first problem. So we know we're going to be working with the hyperbolus. We know it should be a minus in between, which they all are. I'm looking here and I'm like, okay, well, what are the differences? The first thing is that these two have an x squared and these two have a y squared. Well, how do I know which one comes first? First thing is I look to see where the parabola is, and I look here and notice that they are up and down, and the y-axis goes up and down. So that means that that y value has to be the one that comes first. So it has to be one of these two. It cannot be this one or this one because they have that x squared that comes first, that positive x squared. So I know it has to be because these open up and down and the y-axis is up and down. It has to be one of these two. So now I need to figure out which value is going to go under it. Is it the 8 or is it the 5? Well, I look here. Here's going to be where my center is. The distance from my center to my vertex is a value of 5. So that means that it was going to be that 5 there underneath. And so I already know it's going to be this one, but I can also look here that my B value is going to be a value of 8. That 8 is going along the x-axis. So that's going to be the value that goes under my x, and there's my equation right there. So you didn't have to really do the whole thing because you're able to cross things off as you're looking at them. Alrighty, so my next one, which points are going to be the vertices? And so sometimes you guys just try to do stuff in your head and don't throw yourself off and accidentally switch your values. Instead of a -10, 0, you have 0, or instead of, it should be this one, 0, -10, but you put -10, 0 and choose that one. Like, don't throw yourselves off and make silly mistakes. So just do a quick little sketch. This right here is telling me this is my a squared, it's under my y value. So this is telling me that my a is going to be 10. This is going to be my b squared, so it's telling me my b is 2. So I look here, my center is going to be at 0, 0. And it's underneath my y is my a, that is 10. So that means along my y-axis, I'm going to go up 10, down 10. So up 10, down 10. This means along my x-axis, I'm going to go 2 to the right and 2 to the left. And so I can see what my ellipse is going to look like. It looks something like that. And it asks for your vertices. So make sure you are paying attention to what is it asking for. In this case, it is asking for vertices. So here's a vertice, here's a vertice, and each of these points is going to be here at 0, 10, and this is at 0, -10. So here's the correct answer. So make sure you know what you're looking for. So vertices versus co-vertices, and make sure that you have them in the right direction. Don't make silly mistakes and accidentally choose -10, 0 and 10, 0 because those are the same numbers in the wrong order. All right, next one. So this one, okay. So it says we have an ellipse. So we know we're working with an ellipse, we're good there. And the center is at the origin. A vertex along the major axis is here. So I have a vertex at 20, 0 and a focus at 16, 0. The equation of ellipse is this form right here. So we know we're at the center. So in other words, here's my equation, my A and my B. I don't know what they are, but it says, what is the value of B? So what is the question actually asking? We need to make sure we know that. So I really just want the value of B. What do I know? So they gave me some values here. And again, put it on a graph. It just needs to be a little sketch, because otherwise, when you guys look at this, you're like, I don't really know what I have. I don't know what all this means just by looking at it. So we know that we have the center of our ellipse is going to be here at the origin. So here's my center. I have a vertex along the major axis at 20, 0. So I know I have a vertex here at 20, 0. There's a vertex. So you know what else I know? I also know that I would have one here at negative 20, 0, right? I have a focus here at 16, 0. So I have a focus here at 16, 0. So I would also have had one at negative 16, 0. Okay, so what information do I know and what am I looking for? Because I know my vertex, I know my A value, because my A is the distance from my center to my vertex. So in this case, I know that A is going to be 20. The other piece of information I know is my focus. And my focus is always going to be my C value, my C distance. So in this case, C is going to be 16. So I know A is going to be 20. I don't know my B, that's what I'm looking for, but I also know my C is going to be 16. And that's important because I know C squared is equal to A squared minus B squared. Remember, when it's a plus here, it's a minus here. So when we're talking about a hyperbola and it's a minus here, then we use a plus here. It's always the opposite. So let's plug in the values. If I plug it in, I can do my 16 squared minus my 20 squared minus, or equals 20 squared minus B squared. So I have 16 squared is going to be 256 is equal to 400 minus my B squared. If I subtract 400 from both sides, I get negative 144 is going to equal a negative B squared. I can multiply those by -1, divide by the negative, so they're both going to be positive. So I end up with B squared is 144. That means that B is going to equal 12. And this is the answer we're looking for. I was looking for my B value, which is just 12. And my very last problem. All right, these ones are ones that are difficult for you guys. Remember, when we talk about the different scenarios, they're always giving us our focus. They were giving us, we talked about, what were the other ones? I can't even remember what examples we did with them when we did the lessons. Usually they have to do something with sound, maybe a theater we had for one of them, but they're giving us the focus value. So keep that in mind, that when they're doing these problems, they're giving us that focus value. So it says a pair of listening posts is 4,000 feet apart. They both pick up the sound, but one of the listening posts sounds is 1.5 seconds after the other posting. Assume sound travels at 1,100 feet per second. Which equation can be used to determine the possible location of the origin of the sound? Let's see if I could speak. Of the origin of the sound. So I know that the listening posts are 4,000 feet apart. I know that it's 1.5 seconds. One hears it and then one hears it 1.5 seconds later. Sound travels at 1,100 feet per second. So all kinds of different pieces. So let's go ahead. When we talk about this 4,000 feet, so here's going to be like where my starting point is. I'm going to consider it the origin. So from here to my post is going to be 4,000 feet. So It's going to be 4,000 feet from my origin or where I'm starting to my post. So this is going to give me, well, wait, actually, let me rephrase that. Let me draw this, hold on. Let me get this a little bit better so we can see what's going on. Okay, from here, from my, so here's my post. Post. Okay, a pair of those same posts are 4,000 feet apart. So these are going to be my 4,000. Okay, so those are 4,000 feet apart. Then from here to here, at that like origin, the center of where it's going to be. They didn't say it's at the origin, but we're going to do it because that's our easiest spot to pick it from. So this would be then 2,000, and this would be 2,000, right? So we're calling this our focus. So each of these then would represent my C value, because to get to the focus, it's always that C value. And so we're talking about this sound here. So it's going to be kind of contained within these areas. And so this is kind of to give you the idea of like, what is the diagram looking like? Okay, so if I had to hyperbolize, then I know I'm going to be using a minus in between, right? Which they're all minus anyway, so we already had that clue. Okay, so here's what else I know. I know then that sound travels at 1,100 feet per second. So I know 1,100 feet. When I say feet per second, it's feet divided by that second. So I can also write it like that if I wanted to. Why did I write it like this? Because one listening post records the sound 1.5 seconds after the other listening post. So how many feet is that going to be? So 1.5 seconds. And the reason why I wrote it like this is because when I look at it like this is the same thing as saying over 1, but these can cancel each other out. So I'm getting that distance. I'm looking for the distance between them, that sound, how long is it going to be, how far is that sound going to be before the other one hears it? How far away are you when that happens? And so that happens at 1,650 feet. Okay, so we're saying then that the distance from where the sound happens, so here, so let's say I hear it at this one first, and then 1.5 seconds later, I hear it over here. Well, how far away is it from where I first heard it till that second one hears it? And so when I look at this, how far away is that going to be? That's going to be my 1,650 feet. So I hear it here first, and then I hear it here. So I can tell you that it was 1.5 seconds, but I don't know that distance unless I calculate it out. So this is happening from vertex to vertex. So since I know that this whole thing is going to be 1,650 feet, then I know from here to here is going to be my A value, which is going to be 825 feet. So from here to here is my A value, which is 825. If I add the A values together, I get my 1,650 feet. It's not an exponent. It's not an exponent. So my question was, is 1.5 an exponent? No, but this is why they get canceled off, why I cancel off my seconds. So if I wanted to look at this, it's almost like this is over that second. It's over 1 second is another way to look at it, so that I know that these seconds and the second units cancel off. So it's just times that value. So it's not an exponent. It's just 1,100 feet times your 1.5. So they're not an exponent, but that's the reason why I'm trying to do this, is because I want to figure out how far apart is the sound. So we know when I hear it, when I hear the sound here at this point, it takes me 1.5 seconds, or it takes the person over here 1.5 seconds to hear it over here. But we don't know how far away that distance is, and that's what we're looking for. That's why they give us this extra piece of information so we can calculate this distance. So we had to calculate the distance between, they only told us it was 1.5 seconds after. So now that I know that, I know my A value. I know my A value. So the other thing is then I know then A squared is 825 squared. That means that A squared, if I plug this in my calculator, would be 680,625. Now this is going along my x-axis. They're opening left and right. So I know it's going to be under my x value. They're all under the x value. So you didn't even really have to figure that out. But I know then it has to be one of these two. It can't be this equation, and it can't be this equation, because my A squared has to be this value here. The piece that we don't know is this B squared. So this is my A squared value. So we need to figure out what is my B squared. Is it going to be, which one of these is it going to be? So remember, if it's an ellipse, sorry, if it's a hyperbola, then I know C squared is equal to A squared plus B squared. So I can figure it out now by plugging in my values. I know that my C squared, or C is 2,000 squared, is equal to 825 squared plus my B squared. So I'm going to go ahead then, I'm going to solve for my B squared. And so I'm going to subtract 825 squared from both sides, which of course is that number. And when I do that, I end up with B squared is equal to 3,319,375. I actually don't even need to find the B value because they leave it as that B squared value. So this is the correct one. So these ones are tricky. These are the ones that you guys probably struggle with the most. So they're giving you your foci values. You need to calculate the distance. So this is helping you figure out that distance between the vertices. And so then you can see your A and your C, and you're usually looking for that B value when you're solving them. That's all I have for you guys today. Best of luck on your test. If I don't see you guys again, you have a great summer. Enjoy. Best of luck with new adventures to come.
Thank you.
You're welcome. You guys take care.